All right, so section 2 of NuGet Essentials, we want to talk specifically about packages as a best practice. And this isn't meant to be focused purely on NuGet, but be a very broad discussions about packages and some considerations around using packages. The one thing to keep in mind is that packages are everywhere. We are running specifically NuGet on top of .NET, but most applications I go into, most application teams, we're not using just NuGet. We're using a variety of package managers. A common workflow on an application might be NuGet and Bower and NPM. And you might ask, well, Kevin, why would we use all these different package managers? Can't NuGet take care of all of our needs? And the answer is, well, maybe not necessarily. You should use a package manager that's best suited for your particular environment. And what I mean by environment is if I'm building my ASP.NET web application and I'm working with C# and .NET Framework, it's beneficial to me to use NuGet to pull in .NET libraries or .NET assemblies. However, if I'm also working on the web portion of it, and I'm doing HTML, I'm writing JavaScript, doing CSS, it might not make as much sense to use NuGet for these different packages when there's other similar packages on Bower or NPM. So let's walk through this pipeline of NuGet, Bower, NPM, and we'll talk about why these tend to be some of the most popular used package managers. So first, Bower. Bower is still heavily used, but it's kind of rolling back in its popularity because most folks who used to use Bower have moved on to just pushing their stuff up into NPM by itself. But what was Bower? Bower was a package manager for maintaining client-side libraries. So if I needed to go download jQuery, if I needed to go download Bootstrap, if I needed to get Font Awesome, all these client-side libraries that I would normally need, I could go to Bower and I could maintain those dependencies through Bower. And that was very well accepted. But what's funny is I have jQuery here, and jQuery was a very popular library up on Bower. But jQuery is also available on NPM. And what's NPM? NPM is the Node package manager. So even if you're not using Node in any of your development, you probably will still have use cases for Node and for NPM. I'm really impressed with how Node has kind of come up as the utility language or a utility framework for everyone. It doesn't matter if your core development is in Ruby or if it's in .NET or Python or Go, you're probably using NPM underneath the scenes for a lot of your day-to-day work, just because so many really good utilities are built on top of NPM. But let's imagine I am building out an application. I was working on this earlier this morning where I have a React app I'm developing. It's a .NET backend and then a React frontend. And whenever I need to add some sort of component to help me do my work, I end up going to NPM to do the installation. I actually had to do this with jQuery a couple days ago. We have a little piece that requires jQuery to function. So I went and I said, all right, NPM install jQuery. It pulled down the jQuery files, and I do a require inside of my ES6 files. So same version of jQuery that we would find up on Bower, it's just it's on NPM. It's a different package manager because I'm finding my React workflow works better when I just embrace NPM. I tend to find when I try to fight the package managers that the package managers will fight back against me. But likewise, jQuery is also available up on NuGet. So all three of these package managers that I might possibly be using all have the exact same package or the exact same files. They're just packaged a little bit differently. Now notice this is 3.2.1. The jQuery up on NPM is also 3.2.1. It's the exact same file, and they also have different maintainers. So the package up on NuGet is maintained by the NuGet community. The jQuery package is actually managed by jQuery. The Bower package was also managed by jQuery, but they have since stopped maintaining Bower, and it's now another person in the community that maintains it. So the big question is, which one do you choose? So, well, let's look at a couple stacks. If I were developing on .NET, I would obviously use NuGet for my .NET assemblies, but I would use NPM for things like my client-side libraries. That's my jQuery, my Angular, my React, my Bootstrap, my you name it, you name it, you name it. NPM is also really useful because we can pull in utilities. If you've ever heard of Webpack or Gulp or Grunt, just to name a few, normally these utilities or command line utilities are all built on top of NPM, and the only way to install them is through NPM. We'll talk a little bit more about that here in a moment. Let's use another example where I might be developing Ruby code or Python code or Go code. Well, if I'm on, let's just use Ruby, I obviously won't use NPM for any Ruby specific libraries or packages. I'll use Ruby gems because it's easy to go install a Ruby gem into my project and just start using it. But Ruby web apps or Rails applications still have a need, the same need that ASP.NET applications have. If I am using React inside of my Rails app, I need to go get React. Well, how do I do that? And I'm not going to do that through a Ruby gem. I'm going to do that through NPM because that is considered the best environment to get React up and running. But these are generally the type of stacks I work with every day. So I'm just used to a lot of these stacks, and I know a lot of people aren't. And we have to remember that packages might not be just code. I mentioned Webpack, Grunt, or Gulp. These are server-side build tools. What's interesting about these, it's like Webpack, Grunt, and Gulp, is I will never deploy these to a client. These always will be something that run on the back end or as part of my development process. Webpack is a lot of effort to set up, but let's say, so here at the command line, if I had Gulp installed, I could just run Gulp from the command line. Well, Gulp is not something I had to go download and install specifically. I had to physically go out to NPM and install Gulp as a global package, meaning I can use it everywhere. Same thing with Grunt. So if I said Grunt, and they're not working because I don't have the configuration file set up. But these are just JavaScript files that are getting run at the command line. Webpack is the same way. And I just happen to have all these command line runners installed, but the command line runners all come because of NPM. You might use a package manager every single day and not realize it. The ones I have screenshots for, have you ever used the Microsoft Store? Or have you ever used the iOS App Store or Google Play App Store? Those are technically just packages. A single file is getting downloaded, and it self-contains all the information that we need to run that particular dependency. And what's really great about that is we can version it, we can update it, and we can easily remove it. If you run legacy applications on Windows, have you ever run an MSI or some sort of install shield process? Well, it runs through its script and it installs 50,000 files on your hard drive, and it adds a bunch of information to the registry, and it does all this stuff to your computer. And then when you try to remove it, it can't necessarily remove everything because it wasn't a tight package. Moving towards this App Store model, everything's just a self-contained package. So if you want to delete one of your apps, so I want to delete the Hulu app or delete the Adobe Photoshop Elements app, I just remove it and all the digital crud that was with it goes away for the most part. There's other package managers out there. Here's one called Chocolatey that's really taking off because actually a good friend of mine, Rob, who was kind of leading forces behind Chocolatey, said, I see what folks are doing with NuGet, where I can just real quickly install a package. And that's fine for Visual Studio because, so, all right, well, click a NuGet install. I get all these assemblies. It's automatically referenced. But I want to use this for other things that I might install on a regular basis. If you've ever built a computer from the ground up, you might understand where this is really useful. New installation of Windows. What do you spend your first 3, 4, 10 hours doing? Well, you have to go get Visual Studio. Well, you have to go get Office. Well, then you have to go get Chrome or Firefox. And then, all right, well, let's install SQL Server or MongoDB. And I hope you know what I mean is you go through the checklist of all the software that you use every day that requires you to physically go get an installer, download it, run it, and eventually you get your entire environment set up and ready to go. With Chocolatey, they said, well, let's use the same mechanism that would be used for NuGet, which is just a package file or a set of scripts, and let's use that for real software. So if I want to download a utility, I can just use Chocolatey to say, all right, go install Git. Chocolatey will download a package file that says, all right, we will go get the installer. We'll do a silent install, and we will dictate where all these files go. So maybe they don't go to the default program files folder. Instead, they go to a special Chocolatey programs folder. Because if you want to say 2-3 months later, let's get rid of Git. Well, you might not get rid of Git if you installed it manually. There might be some digital cred left over. Chocolatey makes sure that all that digital cred doesn't stick around. It helps you in the cleanup process. And actually, here in a couple of minutes, we'll talk about a utility that I installed via Chocolatey just because it was easier. The manual install process was just way too hard, but Chocolatey made everything easy. And also, I don't have screenshots, but App Store on iOS, Android, etc., they're all package managers. And the reason they're package managers is that we're talking to a single library. The Windows App Store talks to the Windows App Store repository. iOS App Store talks to the iOS repository. So there is a single place where all these packages exist, and I can quickly and easily install them and remove them. And then better yet, if I need to do any updates, updates are a cinch. Click update, and then within a couple minutes, I have a completely new version of the application. It's just there and it's ready to go. Now, as we start talking a little bit more in depth about packages, there are some considerations that you should take into account that you might run into issues. So first of all, packages are only as good if they're available. And what I mean by this is if you build your application around a package and maybe a specific version of a package, what happens if a week or a month or a year later, that package goes away for some reason, or that version of a package goes away? Remember when I was showing you NuGet.org, Newtonsoft.json had a lot of packages inside of it, or a lot of package versions inside of it. Well, what if I was reliant on one of those really old versions and James Newton King said, well, let's just get rid of these old versions in NuGet. No one's really downloading them anymore. Well, he has now broken your application because you can't physically get access to the old version of the file that you used to have. And this brings me to a story about a package called LeftPad. Depending on how much attention you were paying to the internet within the past couple of years, you might have already heard this story, but I think it's really entertaining because it has proven this potential issue time and time again. So LeftPad is an NPM package that basically has one job. And what's that one job? Well, it pads strings. So if you tell it, I am going to give you a string and I need to pad so many characters in length. So foo is 3 characters long, but I really need a 5-character string. Let's pad the left side of it with 2 characters. So likewise, I have a number 17. I need a pad with 5 characters, but I don't want spaces. I want the number 0. And left pad will do that for you. And I know what you're probably thinking, Kevin, this is what, 3 lines of code, if even that, to implement on my own. Why are they downloading a package to do this? Well, that is an excellent question. And there's an entire philosophy behind it. I don't particularly agree with it, but a lot of people use this because something happened. LeftPad was really popular. It was downloaded over 500,000 times in a single month. There was an issue with the organizer, the developer of the package, and he didn't mean to break the internet, but he decided in a fit of rage that he was going to remove all of his packages off of NPM, including LeftPad. Well, when he pulled LeftPad off of the NPM repository, there was a domino effect across the internet because a couple really big core packages in NPM, for example, Babel, which is a package that will translate ES6 or ES7 code to ES5. So we can support older browsers with newer JavaScript. Well, it relied on LeftPad. So every system that relied on a dependency that went and pulled down LeftPad, well, they all broke. And this isn't people sitting at their computers typing npm install LeftPad. These are build systems that are running automatically, and builds that would have normally successfully built are now failing because of this particular package no longer existing. And you can still go back through old GitHub issues and people say, hey, why is this not building? It's telling me it can't find LeftPad. And it all comes back to a Hacker News discussion where the organizer says, hey, I'm pulling down my package. I don't want to participate in this anymore. This triggered a cry throughout the community that this shouldn't technically happen. If you have a package up on the repository and hundreds of thousands, if not millions of people rely on this package, simply being able to remove it can't happen because there are too many dependencies. So the NPM team came back and they made improvements to NPM to ensure that this would not happen again within the NPM infrastructure. This also opened up a huge vulnerability in the system, because let's imagine I was let's say a dishonest developer who wanted to see what I could do to inject some ill will onto the world. Well, when LeftPad was removed from the repository, that left a gap in the repository that could have been filled by a hacker who built a potentially bad package called LeftPad, deploy it up to the package repository, or push it up to NPM. And now all these build systems kick in and they download LeftPad, and maybe my bad package still does what LeftPad is supposed to do. However, I also inject some bad code that allows me a backdoor into any of their systems, or gives me critical information about their infrastructure, or tells me environment variables, which environment variables might have database codes or API keys. There's a lot of bad stuff I could do with having access to a very popular package up on a repository. So it's actually good that this happened, because everyone realized, wait, all this really bad stuff could have happened. So let's make sure that we prevent these issues from ever occurring. And so luckily LeftPad is no longer an issue. So NPM was itself vulnerable, but this should lead us into a discussion of vulnerabilities, because software is maintained by humans, and humans by nature are fallible. We make mistakes, sometimes on purpose, sometimes on accident, and no amount of unit testing or any of that crap will ever protect us. So how do we ensure that the packages we are using are safe? Like, how do we know that James Newton King developing JSON.NET didn't accidentally introduce an issue in the JSON serializer that only comes into play when I run the code with a certain set of input. Now, we don't know that, but people out there are actively looking for these vulnerabilities. And that's kind of the nice thing about open source software in general, is that open source software, because everyone can read it, everyone is reading it. And these popular projects like Newtonsoft, and jQuery and Angular and React, they have hundreds, if not thousands of eyes all looking in the code, and people going, wait a second, what if we had input that did X, Y, or Z? That would cause an issue. By having all these eyes in software, people are seeing these issues and they're detecting these vulnerabilities. So stuff is getting fixed faster. Compare this to 10, 15 years ago, where third-party software developer would develop something, put it out there, everyone would use it, and 6 to 9 months later, someone figures out, hey, there's an issue if I do X, Y, or Z. Well, then it's up to the software developer to patch it, and that might take 2 or 3 months, and then eventually get that patch out to everyone. That might take another 2 or 3 months. Vulnerabilities could live out in the wild a lot longer than they would necessarily live now, because people are out there looking at it. So it wouldn't be nice if there's a library where people are telling us about different vulnerabilities out there in the ecosystem. And there is one. There's the open source index. So we'll go to ossindex.net. So the open source software index is basically looking at all the package managers out there, and it will tell us about vulnerabilities in those packages. So let me start with NuGet, but I can also look at NPM Bower, Maven if I'm doing Java, Drupal, so on and so on. And what the open source software index will do is it will tell us, hey, certain packages up on NuGet have vulnerabilities. Now, when we say vulnerabilities, it means really any type of vulnerability, severe versus maybe not as severe. Well, we could go through the list here and say, oh, all right, there's a bunch of stuff in here. All right, here's everyone's favorite package in the world, jQuery. jQuery has a vulnerability, or specifically the NuGet package of jQuery has a vulnerability, exceeding stack call limit denial of service. Well, if we go click on jQuery, it'll bring up that package, and it gives us some of this information that we would normally get from NuGet.org, but it also tells us about several of the vulnerabilities that versions of jQuery have had. And this is useful for us because we can go through all these different vulnerabilities and say, okay, does this really affect me? What's this one? The jQuery framework exchanges data using JSON with blah, blah, blah. Well, here's a link to all the details about that particular bug. We can go through and they'll tell us how complex the problem is. There's a score. I actually don't remember what the range of the score is, so I don't remember if 5 is really, really bad or not really that bad at all. But if we go through here, there's a lot of different things, and they tell us specifically what versions are affected. If I'm running jQuery 3.1 something, well, older versions of jQuery that run 1.7, not a concern of mine. So it's really interesting to go through here and look at all the different versions of vulnerabilities that we have. But this by itself is not particularly useful, is it? Because any one application I'm running might have dozens, if not, well, it's more like dozens of dependencies. But very large-scale applications might possibly have hundreds of dependencies, or it's dependencies of dependencies of dependencies. If we go down through that tree, there's a lot of stuff to research. And I don't have the time, and I don't expect you have the time either, to go through and look at all these different versions of packages just to see which ones are good, which ones are not good. Should I be worried or should I not be worried? So wouldn't it be great if we had a tool that would do a lot of this work for us? Well, thankfully there is. So not only does the open source software index have the repository of all the vulnerabilities as they know it, but they also have some tools called Dev Audit that will scan our package manifest. That's our package.config files, also package.json files, etc. And it'll tell us which packages are vulnerable and should we be worried. So if we go to that URL that I just showed, there's a couple interesting things to point out. So there's a command line interface, but there's also a Visual Studio extension that will do this for you as well. More importantly, we can install Dev Audit through package managers. So you could install just the MSI. You could just go download the files. You could build it yourself. Or you could use Chocolatey. Chocolatey, remember I just said a moment ago, is a package manager. So if I go to chocolatey.org, there we go. Now I already have Chocolatey installed, but Chocolatey is really one command line to install. You simply open up a command prompt, and they give you the command to paste in. So Chocolatey takes all of 10 seconds to install once you have it installed. So let me go back to my working folder. To install anything, you just say Choco or Choco install, and then they tell you install Dev Audit. Now I already have Dev Audit installed, but there's no harm running it again. Now Chocolatey will go to the Chocolatey repository, and it'll pull down the package. The package has the manifest or the instructions of how to install Dev Audit. And this is coming back and telling me, hey, it's already installed. Would you like to upgrade, or do you want to force a reinstall? I'm not going to force it at all, because if you force anything, it might break, and I really don't want to break it right now. But if I didn't have Dev Audit installed, it would go download the appropriate files. It would put them in the right place. But most importantly, it would make it available at the command line. So the path is updated, so I can run this anywhere I want to inside of my system. Now I'm going to go run Dev Audit on a old demo that I wrote a very long time ago. If I go to cd/consult with SMS word count. So SMS word count was just a little demo I wrote for testing Twilio apps, where you could text message a word or phrase and would respond with the string length, whatever the length of it was. But what's great about this particular project is I haven't touched it in a while. So the packages that it was installed with have not been updated. And that is good fodder for Dev Audit. Now the important thing is when I run this from the command line is I'm in the same directory as my CS proj file or my packages.config file. Because Dev Audit is going to read those files, it'll look at the package name and it'll look at the package version, go look at its database and see if there's anything I should be worried about. I can run Dev Audit by just simply saying Dev Audit NuGet. And by telling it NuGet, I'm telling it go look for package.config. All right, I have 24 packages. It's going to scan the open source software index, and I have a couple issues. Now this isn't the best interface right now because I have a high font size and there's just some wrapping. But let's walk through, and you can obviously see that I have some problems. ASP.NET Razor, blah, 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 blah. These have no known vulnerabilities. We can rest assured that there's nothing that we really have to care about. But at the time, I do rely on Bootstrap version 3.0.0. And this one is vulnerable. And they tell you, you can't miss it, vulnerable. And it's not that it's just vulnerable. Bootstrap has multiple vulnerabilities, 2 known vulnerabilities, but there's only one that's affecting the version that I have installed. Luckily, this code is not running anywhere publicly, so it's not a big concern of mine. But if this was on a public-facing website, I would be a little bit worried because we have a cross-site scripting issue. Well, this tells me that certain versions are affected by the vulnerability, I might want to go update my version of Bootstrap as soon as possible. If I scroll down, jQuery's always got something wrong with it, but jQuery is also a very busy package. They're always working on it. And I'm also referencing a very old version of jQuery. So if someone notices a vulnerability in old versions of jQuery, even though we're on version 3 point something, it's still useful to know the vulnerability because people are still running on these old versions of jQuery. Not everyone has moved up to the latest and greatest. So this is really good from my standpoint, from your standpoint, to quickly assess what we need to know about the packages we're actively using or actively including in our application. Now you will have some cases like here's Microsoft ASP.NET MVC. There's a known vulnerability for the package, but there's none affecting what I have installed. So if I go look this up on Open Source Software Index, I'll see some stuff about ASP.NET MVC. Scroll down, Modernizer has vulnerabilities. These are things I might either want to remove completely or I want to make sure I'm upgrading to the latest and greatest version. Normally, in a lot of these cases, there's links. So I didn't pre-check this, but let me go to, let's go look at Modernizer on the Open Source Index. All right, so we'll say Modernizer. There we go. Okay, so I found the vulnerabilities that Dev Audit was complaining about because they affect my older version of Modernizer. But not only that, it gives me links to GitHub issues. So if I want to go read the progress of this vulnerability as it gets fixed, that's the great thing about open source software. All this stuff is done out in the open. So security alert for one of the dependencies. There's a bunch of information in here. But then you can see what's happening and someone's fixed it and it's closed the vulnerability, meaning if I upgrade, I shouldn't have the vulnerability anymore. Not all packages have this level of detail, but most of them that are hosted on GitHub probably will. So in DevAudit is a good thing. You can also run it through a build system. So if you wanted to commit your code, it goes through a build process, run vulnerability testing, and then maybe email the results to someone on your team. There are a lot of tools out there that will do this for you. There's also a Visual Studio extension that will look at your NuGet packages inside of Visual Studio. I don't have it installed right now, but I know it exists. But that's really useful to have if everyone has that installed and people are adding new packages on the fly. We can quickly assess how vulnerable our application is to different vulnerabilities. Now, again, this is not across the board protection. It's kind of like antivirus. Antivirus isn't perfect, but it catches most things. Dev Audit and the Open Source Index will catch most things in the popular repositories, but they're not checking things like my little flow route project. Like if I just search for flow route. All right, so my package is here, but there's no known vulnerabilities. They're also probably not scanning for anything. It's not across the board protection. So next, in terms of vulnerability, we should also talk about licensing, because there is this thought that open source software means it's just free software, and that's not entirely true. Open source means it's freely available, but you might have some licenses you have to deal with in order to use the freely available software inside of your software. And depending on your organization, you really might have to take this seriously. So before I talk about licensing, I need to reference I am not a lawyer. Please take everything I say with a grain of salt. Do your own research. And if you're a member of a large organization that does employ very actual lawyers, you should probably talk to them about some of this stuff and see what's important versus not important. The part I need to point out is that licensing, there are a lot of licenses. If we go to opensource.org/licenses, they will tell you about most of the licenses out there. And in general, we really only worry about the quote popular licenses, the Apache license, the BSD3 newer revised license, the GNU general public license. MIT license is very popular. There's also things like Creative Commons or the Mozilla public license. And most good open source software will have one of these licenses. And they're pretty unrestrictive. And they'll say, you can use our stuff. We want you to use our stuff. Some of them might say, just tell people that you use our stuff. Or they say, if you alter our software, you have to make sure that the new version is freely available. A lot of them will say, well, if you update the software, commit it back into the main project so everyone can have the benefit of the changes that you've made. It's against the license that if you take someone's code, you change it or let's say improve on it, but don't give it out freely to anyone that might want it. That's breaking the license. So there's a lot of licenses out there. Which one you use, which ones you consume, really depends on you. And this actually came to light a couple weeks ago because of React. And hopefully everyone on the chat has heard of React. It's a very popular client-side framework by the folks at Facebook. But it was licensed specifically under a license called BSD plus patents license. And no one noticed this, I guess. And folks were using React all over the place. They said, this is the greatest thing we've ever used. No, don't use Angular. Folks were really passionate about React and everyone was using it. But some of the licensing bodies came and said the BSD plus patents license is very restrictive. And no one really understood that until a couple good folks jumped in and asked the what if questions with the BSD plus license, patents license. And generally what it says is that you can freely use React. It is copyrighted by Facebook. It is used by Facebook or owned by Facebook, and they are granting you what's called a usage license. So you can use React in any way, shape, or form, unless you want to sue Facebook. So here's the example. All right, so if I want to sue Facebook, if I infringe on any of their patents, or if I have a patent that they might possibly want to have, any of those use cases automatically revoke my license to React, meaning I cannot use React anymore. And the best example that I saw when I was reading up on this a couple of weeks ago was, let's imagine you're building an interface for refrigerators. And your interface for refrigerators, so like a refrigerator touchscreen, and you use React on the front end because React is a really good framework. So you use React, you build out your interface, and everything's great, good to go. But Facebook, it wasn't good enough for them to get into the virtual reality stuff with Oculus. They now want to get into the refrigerator market. So by getting into the refrigerator market, they want to basically build the same thing that you have already built. So you're kind of the market leader on refrigerator UI technology, and Facebook wants a part of that action. Well, because they want it and you own the patent or the claim to it, the fact that they just want it now invalidates your patent or invalidates your usage license to React. So if you were to go to court over this and you get up in front of the judge and you say, look, we have this technology, we're not going to just freely give it to Facebook. Facebook can come and say, well, you're technically using it illegally, or you built it illegally because we don't grant you a usage license to React, to use React. So all your months and months, if not years of development effort for your awesome new patented refrigerator UI technology, it's all mute, because the fact that Facebook wanted it and would go after it invalidated your usage license. And this is a very dangerous situation. Even though Facebook came back and said, no, that's not what the purpose of it was. Our lawyers told us to use it, but we would never do that. And And most of you, you can trust Facebook, right? I mean, I trust Facebook. We all trust Facebook. Well, the community came back and said, all right, this is not acceptable if you're using React. We strongly encourage you to stop using React. And enough people's voices were heard that on September 22nd, Facebook changed the license. And it's now relicensed under a, a less restrictive license. I don't remember exactly which one off the top of my head, but I have a link here on the screen to the React relicense where Facebook says exactly what they were trying to do. And so it's a good read. Everyone can use React again. Life moves on. Now, really, should you be worried? And it depends on what type of business you are. I am an independent software developer. I work on very small projects in the main scheme of things, but I have worked for very large businesses, and large businesses have, most importantly, money. They have employees, they have risk. So if I was a big business, maybe a banking company or some sort of government agency, I would be worried because I have now given way too much power to Facebook over the control of my well-being, of my software. If you're just a little independent startup, you probably wouldn't care because there's very low odds of Facebook taking you to court over one of these things. And as with most open source software, you could probably break the license every which way you wanted to. No one's going to notice because you're not big enough to matter. But if you're a big business, I use banks as examples. Banks have money, so people are more likely to sue a bank because they have money, and they'll pay the people off to get them off their backs. So the questions about vulnerabilities and licensing and everything brings us back to package managers. And can a package manager protect us against ourselves? Now, NuGet npm, gems, they don't normally do vulnerability testing out of the box. We're starting to see some of the more popular ones do vulnerability testing. Anyone who's used Docker, the Docker repository will do vulnerability testing on a regular basis. So they're starting to do this on their public images. But NuGet doesn't do any vulnerability testing for you. Open source software index has to go into NuGet, pull out the package and do the vulnerability testing on their own. But if they don't do it, you have to do it. Or if you're using NuGet, you have to go look at the index to see what's broken. You notice I just was at the command line and had to run dev audit. That's a slightly manual process. Couldn't a package manager help us? And the real answer is a commercial package manager will help us. I use the example of ProGet. ProGet does this inside the box. So if I am building a private package management system for my team, my dev team, I can support all the different package managers out there, NuGet, Bower, NPM, et cetera, et cetera. And I can still use the public packages. So all the stuff on NuGet, I can still use through my repository. All the stuff on NPM, I can use through my repository. But what something like ProGet will do is it will go through and do vulnerability detection for me. Instead of me going and checking every package that might possibly use in our infrastructure, ProGet will do that. And it will tell me, is this version of a package vulnerable or not? It will do alerts if packages are vulnerable. Likewise, license management. Maybe our lawyers say, these are the only packages you're allowed to use. The MIT license, the Mozilla open license, etc. Don't use anything that doesn't use one of these packages without prior approval. Well, package management is kind of the Wild West. I could just go to NuGet and install anything I want to. And even though NuGet will tell me what the package license is, it's not going to stop me from installing. ProGet will. ProGet will hide packages or at least warn against packages that don't meet your license criteria. So if I tell my developers don't install the BSD plus patents license, and someone says, oh, well, this is a great application for React. Well, ProGet won't let us even install the package because it doesn't meet our license requirements. So we're starting to get into the opportunity where commercial package managers really become a good thing for teams bigger than one, because I can support all my different package management suites, NuGet, Bower, et cetera. But then I can add all these other features on it. And then plus that, I can support private packages. So if I start developing my own stuff, my own kitchen sink utilities, I can take these packages and put them up in our private package manager, and only my team has access to it, or anyone that has access to the private package management repository.